Hello, let's solve this integral I equal to integral 0 to infinity 1 by 1 plus e power ln x whole square dx. So let's start. This I can be written as integral 0 to infinity 1 by, if you take e power ln x square as common, then we are left with 1 plus e power minus of ln x whole square dx. Fine. Then this term goes in the numerator. This will be e power minus of ln x whole square by 1 plus e power minus of ln x whole square dx. So let's simplify this term first. This is e power minus of ln x square, right, into 1 plus e power minus of ln x whole square whole power minus 1. E power minus of ln x whole square into 1 plus x whole power minus 1 is 1 minus x plus x square minus x cube and so on, right? Then this will be 1 minus of e power minus of ln x square plus e power minus 2 into ln x whole square minus and so on. Then this will be e power minus of ln x whole square minus e power minus 2 into ln x whole square plus e power minus 3 into ln x whole square minus and so on. So let's write it in the form of summation. It will be e power minus of ln x square. As you can see, for the first time the quotient is 1, for the second time it's 2, for third time it's 3. So you can write it as summation n equal to 1 to infinity n. For the first time it's 1, right? Then there is alternating plus and minus symbols, right? For the second term it's minus, for the first term it's 1. So this will be minus 1 whole power n plus 1. So when n equal to 2, this will be minus 1 whole power 2 plus 1, which is minus 1 whole power 3, which makes it minus. So there is a minus symbol here in the second term. Fine. Then let's write I, which is equal to integral 0 to infinity summation n equal to 1 to infinity minus 1 whole power n plus 1 into e power minus n into ln x whole square dx. So let's bring this summation n equal to 1 to infinity minus 1 whole power n plus 1 out of the integral. Then this will be integral 0 to infinity e power minus n ln x square dx. So let's make some substitutions here. Let's consider t square equal to n into ln x whole square, right? Then t is n into root n, right, into ln x. Then t by root n equal to ln x. Then x is e power t by root n. Fine. Then dx is e power t by root n into 1 by root n dt, right? Then we need to figure out the integration limits. Fine. If x equal to 0, if x equal to 0, then t must be minus infinity, right, which is e power minus infinity, then it will become 1 by infinity, which will tends to 0. If x equal to infinity, then t must be infinity. So then I becomes summation n equal to 1 to infinity minus 1 whole power n plus 1. Now the integration limits are minus infinity to plus infinity e power minus t square into dx is 1 by root n into e power t by root n dt, right? So this will be I equal to summation n equal to 1 to infinity minus 1 whole power n plus 1 by, bring the root n part out of the integral, then this will be minus infinity to infinity e power minus of t square plus t by root n, right? You can write it in the form of a plus b whole square. So you can just add 2 into divide 2, right? Then this will be, you need to add minus 1 by 2 root n whole square into dt. Fine. Then this is I equal to summation n equal to 1 to infinity, right? This will be minus 1 whole power n plus 1 by root of n into minus infinity to infinity. This will be e power minus of t. Let's write it like this. This is minus of, sorry, this is t by root n, right? This is t by root n. If you are making the minus symbol, this will be minus, then this will be plus, right? Because you have taken minus out of exponential part, this will be e power minus t square. Minus minus will become t by root n. Fine. That was a small mistake. Then this is e power minus of t minus, right? T minus 1 by 2 root n whole square plus 1 by 4n dt. Then this I is summation n equal to 1 to infinity minus 1 whole power n plus 1 by root n. As you can see, this e power a plus b is e power a into e power b, right? Then this will be e power minus t minus 1 by 2 root n whole square into e power 1 by 4n, which is constant because there is no t dependency there. You can bring it out of the integral. Then this will e power 1 by 4n. Then the integration will be e power minus of t minus 1 by 2 root n whole square dt, right? This you can solve by taking these integrations as t minus 1 by root 2 root n equal to some v and so blah blah blah. But let's apply a trick here. As you can see, this integration is in the form of a Gaussian integral e power minus alpha x square dx equal to root of pi by alpha. Here this functions looks like, I'm sorry, this is the part will be here, right? This will be 1. Fine. As you can see here, the function for this is the similar case. If it's, this is e power minus alpha x square. If the function is x minus a whole square, if the function is e power minus alpha into x minus a whole square, it's the same function which is shifted towards a. That means the highest point is shifted, that is at this point it's highest. x equal to a, then this is y, which is e power minus alpha into x minus a whole square. If you are integrating it from minus infinity to plus infinity, then shifting but doesn't matter because it covers every area, right? So here it's just nothing but the same formula. Here is alpha is 1. So I equal to summation n equal to 1 to infinity minus 1 whole power n plus 1 by root n into e power 1 by 4n. This will be root pi by alpha. Alpha is 1, right? Into root pi. So finally write it down. I is integral 0 to infinity 1 by 1 plus e power ln x whole square dx is root pi into summation n equal to 1 to infinity minus 1 whole power n plus 1 into e power 1 by 4n by root n. So this is the final solution.